and welcome back. In our second video with exponent rules, I want to take some time to look at zero exponents and negative exponents. We've already talked about what they mean in class, so I'm not going to spend too much time on that now. This is more about how to simplify with them. Let's look at our first problem. I will begin by working in my numerator. We have 2 to the 5th power. We have m to the negative 2 times 5. N 7 times 5. Ten times 4, so m 40. N negative 12. I'm just using my multiply rules there. Now I'm going to store it in my denominator, 4 to the 2nd power. M negative 6 and negative 4. That was my first pass through on the problem. In my second pass through, I'm going to combine, and then I can begin to simplify. So I have m negative 10 and m 40. Together that's going to be m to the 30. I have n 35 minus 12 and 23. And I also have the 32. There's no other simplifying to do in our denominator. And now I can begin to work on my final step, our division. 32 divided by 16 is 2. M to the 30th minus negative 6. Or you could also think of those 6 negatives having to move up into the opposite side, our denominator. So that will be m 36. And the 4 negative n's will go up as well. Or you can think of it with subtraction rule, 23 minus negative 4 and to the 27th power. For our second problem, we now have some 0 powers as well. Remember, that just means 1. So this whole part of the problem, I can just cancel out because it's really 16 and a 1, 16 times 1. That makes life easier. X, 4 times negative 1. 8 times negative 1 for your y's. In the denominator, 7 times 3. Negative 3 times 3. Now that we've simplified our numerator and denominator, we can begin our division. No other whole number bases. Leave the 16. For the x's, negative 4 minus 21 would be negative 25. You can also think of that as these 4 having to go into the denominator, which will end up leaving us 25 x's. Negative 8 minus negative 9 would be positive 1. You can also think of those 9 having to move up, leaving you with 1 y in your numerator. For our last problem, I want to look at an example that has given some students a little bit of trouble in class. That's what happens when you have a base that's a number that goes to a negative power. So we'll look at that. First, as always, I'm starting in my numerator, and I'm canceling out any 0 powers. Then the denominator. And again, beginning with the numerator, 2 times 2, a to the third, and 5 b's, b to the 5th power. It's here where things get a little interesting. You have 2 to the negative 1. Oops. And you have a negative 1 times negative 1, which is just 1a. So let's look at what we can cancel. I'm going to do that 2 to the negative 1 last. We can take one of these a's. We'll cancel with one of those, making that 2. We can't cancel the b's at all, so we put a b to the 5th power there. And this negative first power on the 2 means that 2 actually needs to go into our numerator. So we're going to have 4 times 2. So when this ends up simplifying, we have 8, a to the 2nd, b to the 5th, and there is no denominator, it's all over 1, so we don't need to write it. Again, to summarize, negative exponents, you can move them to the opposite side, and you can use your subtraction rules when you divide.